All right. So this week's guests are the co-creators of a new tool that I've promoted called Fastdup, Danny Bickson and Amir Alush. Welcome to the Data Exchange Podcast.
Hello, Ben. It's a pleasure to be here.
So this is a tool for computer vision, and computer vision was, basically instrumental in the resurgence of deep learning, along with speech recognition. But the reality is, most data teams may not be as familiar with computer vision as you guys. So tell us, what is the state of computer vision tools? And I'll start with you, Danny. So someone wants to work on computer vision. Let's assume they've collected images, right? So what's the stage of tooling for computer vision these days?
Yeah, so we did an internal survey from our both our experiences at Apple and some startups, but we also connected with many companies, more than 100 companies, to understand what are the pains. And the general outcome is that there aren't enough tools for working with images. So there is a great progress in deep learning packages like PyTorch, TensorFlow. That's amazing progress. It's pretty much, people say that it's pretty much solved the infrastructure there. But from the other end, simple tasks when working with images, for example, I got my images on an S3 bucket and I need to preview them. So I don't have support for that. I need to write my own code for that.
So as far as models, what you're saying, so Amir, you can feel free to jump in here. So as far as modeling, we're in a good state, but before you start modeling, we're still kind of struggling.
Yeah, exactly. So from my experience working for the last 15 years in computer vision, I've actually was in charge of developing very large-scale data collection, data curation, also model development. The toughest work is cleaning the data, handling it, and so forth. And nobody actually wants to do that. So I guess a lot of toolings are still missing there. And throughout my experience, every company I've opened or either worked with, we always started writing our own tools from scratch, always reinventing the wheel. And it's actually a never-ending work. So So at one stage in my previous startup, we actually were actively looking to purchase tools, somebody to take off some of the tasks. And we didn't find any relevant or interesting companies in that arena. So we ended up doing some kind of a hybrid solution. So a lot of the infrastructure we wrote ourselves. Some of it we used external tooling, but it was not a complete solution, not even close to it.
So in other areas of data and ML, right? So you have the data scientists and to some extent ML engineers on the building, training models, deploying them to production. But then you've got this group of people, data engineers, platform engineers, who are focused on data management, pipelines, data wrangling, data cleaning. So Danny, you conducted, I forget how many interviews that we kind of summarized in our blog post, which I will link to in the episode notes. So who did you talk to? And what was the format of the interview? Was it quite formal in the sense that you had a list of questions? And what were the findings?
Yeah, so I think overall we talked with more than 150 companies. There are a lot of companies doing computer vision in production, a lot of interesting use cases. The typical persona was ranging from computer vision researcher, computer vision engineer, and sometimes senior director computer vision. So we talked both to juniors and seniors.
And so what were the key findings?
So first, everyone agrees there are not enough tools, and most companies wrote their own ad hoc scripts, and most companies said, we started a few years ago, we didn't have anything, we wrote stuff, but now it's hard to change. And
so when you so just to clarify, when you say not enough tools, it's that stage in the pipeline around data that you're talking about, right?
Yeah, absolutely. Everything around images. So when you work with images, it's a bit of an annoying form of information because you have raw images which are kept in a network share or S3 bucket or somewhere, and you have metadata for the images, like when was the image taken and who took the image, and that's typically found in a traditional database. And you have annotations which are bounding boxes, and they can be nested, so they are typically stored in JSON file formats. And then you have to write code to actually look for things and find where is your information. So it's when you say, give me an image and all its information, then you have to write code to look for it.
So right now, what did you find? So you found people basically building their own tools or not dealing with this at all, or so what's the current
Yeah,
situation?
so companies write their own tool, and I was surprised to find also some horrible solutions that people sometimes do. For example, if people are used to work with Parquet files, working on tabular data, and they are really familiar with that, so they put images inside Parquet file. Now, it could work, but down the road, they will pay for it in performance, storage costs, and all kinds of other issues that may arise. So we heard about Parquet file, we heard about HDF5 files, we heard about taking images, putting them as a base 64 strings inside a database. All kinds of pretty horrible solutions that may explode on you later.
So Amir, when Danny told you about the findings of this survey, what was your reaction?
I wasn't surprised, actually. Like as a potential customer myself, like someone from the field, I'm deeply familiar with all of these with all of these issues, and I did some of the dirty ad hoc fixing myself, so I'm highly familiar with it because it's highly complicated. When you're talking about images, it's highly complicated. We try to solve it in my previous companies. We try to solve it like infrastructure base, and it took us a very long time, and I can't say we actually managed to deal with it correctly. So I fully understand the gap and the need, and this is why we're actually working on this together.
Yeah. So which brings us to the first tool that you folks have released called Fastdup. So Danny, describe what Fastdup is and why exactly did you settle on this core set of features?
Yeah, so to be honest, we talked to so many companies that it was a bit tiring. And after maybe 6 months, we decided, well, let's stop a little bit and try to write some proof of concept tool that is not a full solution, but maybe first feature to show you can do things with images more easily. So what we started with, we took a very simple task of finding duplicates. That's why it's called Fastdup. And the idea is that whenever you get a data set, there is always noise in it, and sometimes there are mistakes. People copy the data from place to place and upload it, and sometimes the upload is broken, they resume and so on. In many cases, they get duplicates. So it could be either exact duplicates or nearby duplicates, like very similar images. And they waste your storage, and when you send the data for annotations, you may pay 10 times if you tag the same image 10 times, and also it may affect your compute because it's not new information. So we started with let's just do that, and we wrote it. It took a month and a half, and we found out that it's very efficient. We can run on tens of millions of images in a few hours, even without a GPU. And once we had the framework of finding the very similar images, we actually started to also to find outliers. So that's a next common thing to do. And in many data sets, they are very surprising things that you find. For example, on our website, we show that there is a face recognition data set where you have images of radios and shoes and ocean and things like that. So there is all kinds of users information that interferes with the data. So we started with duplicates, then anomalies, and then we also did also all kinds of clustering in order to find regions of similar images. And then we also started to look at labels. So it's kind of grew during the development. But what's nice of it, it's very easy to install. It's just a pip install, and we got amazing reaction from the
it's basically pip install and point it to a set of images. So Amir, what has been the reaction so far?
Yeah, I can tell you what was my reaction at the beginning before I start with others. So I think I had a really strong wow effect. I think when I started using our tool and I started to be like obsessive about checking all public available academic data set, and I was really amazed to see the amount of noise and mislabeling and outliers and duplicates inside academic data sets, which I've been using myself for years. So that was always a wow effect, the fact that we managed to build something that is pretty much generic and it works in an unsupervised way. And it does give me myself as a researcher, it gives me a very strong benefit. So we felt very comfortable releasing it and releasing the results, like to open, like to break some myth perhaps about the current available public data set. And this is actually was the same reaction we got from the community. We started in Israel, so we got a very strong reaction. There is a very large computer vision community in Israel. We got amazing effects, supportive comments, and everybody actually was really thrown and blown out of the results. And a lot of people started actually using it. So I think we got really excited to see that people are actually using the code and getting benefits out of it on their data sets. So that was actually a pretty magical moment, I think, for both of us. And so we got pretty amazing reactions there.
So Danny, for our listeners, what is the precise status? So I go to GitHub, and then can I just use it? So what's the license? What exactly is what are the terms of using this?
So the tool is free. It's free up to 1 million images. So far, we had 20,000 installations in a month, which is pretty nice. And so far, we didn't get much complaints about. So most of the people had data sets that are smaller than 1 million images. And we would love to engage with anyone that wants to explore larger data sets. And we are looking to design partner to work with us, and we'll be very happy to extend
So the 1 million images is more of a kind of an artificial limit, but in principle, if I have like 100 million images, do you think that Fastdup would still work?
Yeah, so actually now we are talking to a customer that has 5 billion images, and we are engaging to help them and make sure everything runs. But I think I really like the large scale arena. So I mean, more than billion images, that starts to be more demanding in terms of the.
So what is so Fastdup runs right now on a single beefy server, or is it, in principle, over time, can it be distributed?
Yeah, so we currently even didn't utilize the GPU because we didn't find yet a data set that needs a GPU. The thing is that there are three things you do. First, you load the image, then you resize the image to the deep learning network architecture size, and then you score you do some inference, you extract a short feature vector, and you build a similarity model in order to.
And Fastdup takes care of all of these.
Yeah, everything is taken care. You just give a folder, you get all the results, and you get also visualizations of what you got in the data. But the nice thing, because the load and the resize of images is actually more demanding than the actual inference part, we found out that even without GPU, we have very nice performance. So we were able to get to 4 million images an hour on a 32 core machine without a GPU.
So Amir, what is the UX right now? It's all command line. And are you folks anticipating at some point you're going to put like a little front end to it?
Yeah, for sure. Currently, it's basically we have the interface is mostly command line. We did add some basic visualization, which works actually pretty nice. And we also did some TensorBoard integration, which actually looks great. So in the near future, yeah, we'll add also more robust visualization there, even though I think it's actually pretty easy to use and pretty convenient to use as is. But as we grow and as we develop the product, of course, we'll add this layer. We're talking about images. Of course, visualization is pretty central to the use case.
Yeah, that's one of the critical things. There are a lot of companies, they build infrastructure, they build pipelines for everything, for text, for graphs, for tabular data, and so on. But with images, you have to take careful attention to actually visualize every step of the way. And that way, it's way easier to debug. So sometimes you can get a data set of million images. I can generate an image maybe composed out of 100 images that is very general and shows you the broad view of your data set, and you understand what's going on inside. And humans grasp it immediately. At Apple, we had manufacturing issues that you manufacture a few million devices a day, you have no clue what's going on there. But when we did a summary of actually all the things, all the events in a single day and lay them on a single image, the factories were blown to actually find that they can understand exactly what happened.
So is there a big distinction in the computer vision community between images and video? So is video, in other words, my question is, since I'm not in this field, does a separate team work on video and then a separate team work on images? And so the tools would be different? So
no, not really. Most of the companies we interviewed are sticking with images. The reason videos are becoming larger and larger. So if they have videos, they have huge amount of videos. Usually they extract keyframes or every, 30 seconds or something and reduce the problem into working with images. There is a small minority of companies that have to work with videos. We heard some cool use cases. For example, online checkout company that looks for cases, for example, 2 customers in the store and one takes an apple from the other customer bins and put the apple on his bin. So that's very complicated to solve without the video aspect of it, because there is a...
So what is the natural, so right now, Fastdup can do find duplicates, anomalies, and outliers, help you kind of identify mislabeled images. Mm-hmm. So what is the natural progression for Fastdup? So what would be the next wave of things that, based on how Fastdup is built and the architecture, what would be the natural set of next capabilities? I hate to put you on the spot, but
no. So currently we basically listen to our users and grow the product around the requests. So there are a lot of interesting developments. So one thing which is very popular today in computer vision are text-to-image models, which are very creative. And right. For them, you need billions of images, which is a headache. So that's one direction to scale data curation to the regime of billions of images. Another common thing we hear is production type applications where you get constant stream of images. Imagine a right. Cardbox sorting facility with robots that need to sort cardboards, and there are 50 different types of cardboard, but suddenly the 51st type appears and they don't know what to do with it. So they always need to signal new new phenomena, new
So basically,
distribution in the data.
the idea there is Fastdup will identify this is a new image. It's new image, so do something with this, either label it or.
Right. Because imagine you have infinite amount of information, but most of it is useless, and you're just looking for the new interesting things. So it's
now we're going into the regime of from batch to online processing, right?
Exactly. Yeah, and it's very similar problem, but slightly different. That's what's fun about it. Other thing we hear from customers are things related to labels. It's super manual work. Most of the labeling companies are doing by humans. They're done by humans, and the quality is not carefully automated to make sure the result is satisfying. And then companies train models, but they are not sure about the quality, and they start to debug, and then they find mistakes in labeling, which is a major headache because it's really hard to debug a deep learning model. It's much easier to debug your data. Final thing that we are hearing, the companies start to use synthetic data. And we initially thought will be useless for synthetic data because companies should really care about the data. Data is their new oil or something, but even companies that purchase synthetic data, they have no clue what they got inside. They have to train a model in order to see whether the synthetic data improved what they got. And training a model may take a week or two of a lot of EC2 compute. So it actually makes more sense that if you want to dive into your synthetic data, understand what you got inside, is it better? Are there different outliers and so on? It's better to do a data iteration before you start training models.
So Amir, so the tasks in computer vision are what? So you're building models, classifier, object detection, this kind of thing, right? So search, is search a big, for me as a consumer of images, I find that image search is important, but I don't know if computer vision teams value search.
So there are a lot of subtopics. Companies are actually doing. Some of them are more on the research side, but I think the bread and butter of computer vision in production these days, I think if I would have to guess based on my experience, it's actually the classical like object detection, very simple image classification, perhaps some semantic segmentation. I think these will be the most common tasks.
And all of those that you named really depend on high quality data.
Yeah, all of the tasks. Even if you want to generate like synthetic data out of a text, it all depends on the data quality, data issue. We also, we hear a lot about model bias. We hear a lot about this in recent years. It also, of course, depending on the data. So if you have bias in the data, you will also have bias in the model, and companies actually are struggling to do that. So you can look at it, that's kind of a smart sampling of the data. So
one of the things that's surprising about this field, as for someone who's not, I work a lot with text and structured data, but never with computer vision, is how under invested the data management aspect of it appears to be based on just talking to the two of you, but other people in the space. It's just, so this is a decade-long march towards better and better computer vision models, but somehow the data aspect of it has gotten left behind. But Danny, I asked you this a few weeks ago. Basically, at some point during the processing of Fastdup, you folks have a vector, but now we have this whole family of things called vector databases. So will those play a role moving forward in this field?
Yeah, I think it's a very useful functionality to have. The problem in computer vision, again, is that most of the vector search engines, let's call it, they assume
that's key. They're used mainly for search, right?
Yeah, but the problem is that they assume you got a vector, and this is the main wrong assumption, because a lot of the teams we've been talking to, that they do have images, they don't know how to correctly extract feature vectors out of their data. And once they get a result, they don't want to get an ID. They want to get the actual, to do something with the results. So it solves a part of the problem. Mm-hmm. And we do have this component in our system, but we found out there are a lot of subtleties. Let me give you an example. For example, the networks, they get the images on a smaller scale. So it's like 224 by 224. And typical image could be 3000 by 4000, and you have to resize it. Now, the way you resize it really affects the performance of the model. And this is a pitfall many teams are hitting. And the thing is that assuming you take a TensorFlow model that was trained on a resize function, let's call it A. It could be, I don't know, PIL library. And then you take your images and resize using another library, let's say OpenCV, and run on a model that was trained on another resize. There is a significant degradation in the result. And then you get vectors, but they're not good enough. The subtleties are not good enough for doing the distinction on the finer grain details. So this is something we hit ourselves. And there is a list of such annoying things that you have to solve them one by one. So we did talk to a few companies that were trying to implement search on their own. And it's typically a 1-year project. And most of the thing we heard, it was, I would call it vanilla, completely vanilla search. But because there is no infrastructure, they really have to take code from the web, and it's kind of sometimes working, sometimes not working, a trial and error process, integration with different systems, and so on. So it's really painful. So for us, it was really important to do one line of Python that you can just run on your old image repo. Everything is under the hood. We could, of course, explain what we are doing. It's not magic, but still.
Danny, in other data types, when you use the word database, right? So then that means you can run queries, you can ask questions, you can have summary metrics, right? So this and that. So what you're saying is that these vector databases, while they're helpful, they may not be able to address all of your needs around analytics for
around vision. I'm just talking about images.
Yeah, around computer vision.
They are a very useful and great tool, but still you have to stitch 5 other different things in order to use them correctly. And there is a lot of work which remains for the companies to do. I do want to mention also another thing that we didn't touch is the lack of standards. So you have 20 types of images and you have 50 types of annotation types, and each one has a different format, and each image library has their own coordinate systems. And sometimes it's their images are stored as RGB, and sometimes it's BGR, and sometimes the X is the Y is the X, and the height, and so on. Everything is so confusing. When you have to work around that or try to replace a lower level library, there's so many problems to it. So we kind of wanted to abstract all those things away, because a lot of the current solutions and the tutorials, they get you into too many details and too many things you have to figure out on your own.
You know, the funny thing about this, what you're saying is, and Amir, feel free to jump in, is that when we read articles, right, so and press releases around AI and computer vision, it's only about the models, right? No one talks about all of this must-do stuff that needs to be done in order for you to celebrate and build a model.
So I think there's a lot more conversation about the topic. I think Andrew Ng and also Andrea Carpati are leading this conversation about the data-centric AI.
Right.
I think it's starting to get a lot more popular. A lot more people are talking about it. And the centrality of the data inside the process, I think it's starting to be heard, and people are starting to understand that.
But it's not, so based on what Danny said, take whatever data-centric problems you have in other data types, multiply that by 10 or 20 for computer vision.
I think I think the amount of data, the amount of compute you need to invest, the size, the physical size of the files, it's what makes this data.
Or just even the different camera types, the different ways they store the images. Just like Danny said, no standardization, right?
It's an unstructured data. Yeah, you have many different formats, and it's a very hard task.
We can kind of wind this down and just focus on what's next for Fastdup. So right now you have kind of talking with some early users. You might engage with some specific design partners, but for people listening to this podcast, should they just start using Fastdup? What's the specific advice?
Absolutely, everyone, every US home and also internationally should use us. But the thing is, the tool is free and easy to use, so we encourage everyone to use it. But most important, we would love the feedback.
So we talked a lot about just broadly a lot of problems in data for computer vision. But right now, what can they expect for Fastdup? What can Fastdup do for me right now?
So we are trying to go on the unsupervised path as much as we can. So we show that we do many things with the single model. We can tackle many data sets, and we can, with the same rough tool of this low dimensional embedding, we can actually solve many different kinds of problems. We want to push the limits and actually show we can do additional things. So one thing we are working on is, for example, object detection model where you have bounding boxes. So it's an interesting problem because you don't look for the Eiffel Tower, but you may look for something really small in the image and find it on another image. So it's kind of a very detailed search for a very minor details.
But Amir, as a computer vision team, what can I rely on Fastdup to solve for me right now?
Right now, so I would run it as a first line of defense to make sure, do a sanity on my data, make sure that I'm not that I don't have any data leakage between train and test, that I don't have any duplicate images, to find out corrupted images, and that's actually pretty fast. It's one line of code. You can actually detect all of this before you're starting to invest on developing the model, because you will get to these errors if your data set does contain them. But it will, in the good case, it will be while you're doing the data annotation manually, so you're just wasting money on doing that. Or the worst case would be that it's going to hurt your model reliability in production. So you'll find it in the second or third or fourth iteration. So you actually, if you can do it in the first step, like the baseline, before you even start writing a single line in PyTorch or TensorFlow, whatever flavor you like, I would start with that.
And this, what you said here is true in the scenario of that Danny painted earlier, the lack of standardization. So I can have images of all sorts of different types, all stored in the same directory, and you folks will take care of.
Yeah, exactly. Yeah. And if we're not, you can contact us directly, and Danny will add support in 2 hours. Danny?
Maybe, I'll try. Yeah, one thing maybe we didn't talk much about is the personas we are targeting, the computer vision teams. So we found out computer vision team are pretty smart guys. They are many cases PhDs or master degrees that are really into the algorithmic side, but very rarely computer vision teams have a strong infrastructure system side. It's typically another team, and they are more database guys and not vision guys, so they fail to understand exactly what they need. And the thing is, imagine what's more exciting, to implement the latest paper from OpenAI or Facebook, or go clean a 1 billion image data set and remove junk. So it's really unpopular tasks. So, very commonly, they're either given to juniors or they're sometimes kind of ignored. So we heard people say, oh, it's deep learning, so it's better to throw junk at it. And, since the data is anyway so big, statistically, it won't hurt, and so on. So that we strongly advise against. And this is exactly what Andrew Ng is saying, that it's really important to have a carefully selected small data set with very high quality, and then you can train much simpler model and have better results.
So at this point, what sorts of images has Fastdup been tried against? So Amir mentioned earlier, basically every kind of open image repository under the sun, right?
Yeah, we had many, but one of the funny things we worked with a self-driving car company that shared some videos, and we found a car driving on the ceiling, which is basically somehow the horizon got to a very strange angle of like 120 degree because simulation has gone wild. So this is type of things we always find in data sets. It's very rare to have a data set that you don't find very weird things inside.
And to close, so you folks have started to talk and hear from people across different industries and use cases. So is there any particular industry where Fastdup in particular seems to really resonate, or is it just across the board?
I think it's very wide. We are talking to construction companies, self-driving cars, internet application, like I would say iPhone app type companies. What else, Amir? Some medical.
And so this runs the gamut. I guess Danny showed me a talk from Amazon. So it runs the gamut from really advanced companies and teams to people who are just starting out, right, Amir?
Right. Yeah. I think everybody likes it. Nobody likes to do the dirty work. So we're trying to save that. And it's also a hidden, I think it's a hidden problem. Like everybody, I don't know. Yeah. Like a lot of companies would like to clean and get us to help with this problem. Yeah.
Yeah. And with that, thank you, Danny and Amir. And we'll have you back here in maybe 6 months to get us an update on the status of Fastdup, and probably at that point, who knows what the project name will be. It sounds like the foundation is there to build more and more features beyond what you have today.
Certainly.
Very cool. Thanks for hosting us.
Thank you, Ben.